Welcome to day 55. Today, we're talking about what happens after all the hard work of training is done. Let's get into deploying deep learning models.
So, you've done it. You've spent weeks, maybe even months, training a model. You've tweaked it, you've optimized it, and now you have a single file sitting on your computer. That's it. It's a pretty anticlimactic moment, right? In this state, it can't really do anything for anyone. So the big question is, now what?
Well, by the end of this session, you're going to know exactly what to do next. We're going to walk through the essential steps to take that lonely file from your machine and turn it into a live, useful application that people can actually interact with. To get from a simple notebook to a full-blown production system, we really just need to understand one core idea.
The official term for this whole process is model deployment. Now, before we get lost in the technical jargon, let's build our intuition with a simple analogy.
I want you to think of your trained model as a perfected recipe. It's flawless. It knows exactly how to take specific ingredients, that's your input data, and create a perfect, consistent dish. That's the model's prediction. But a recipe hidden in a drawer doesn't feed anyone, does it? Deployment, then, is the process of opening a restaurant. It's building the kitchen, setting up the order counter, and hiring the staff so that anyone can walk in, place an order, and enjoy your amazing dish. The recipe is the secret, but the restaurant is what makes it valuable.
So how do we actually build this model restaurant? Well, the whole process can be broken down into a simple three-step framework.
The steps are package, serve, and ship. Each one solves a very specific problem in getting our recipe to the customer. Let's walk through them one by one.
First up, we have to package the model. The technical term for this is serialization. All it really means is converting your trained model, which is just an object in your computer's memory, into a single file that you can save and move around. In our restaurant analogy, this is like taking that perfect recipe out of your head and writing it down on a durable laminated card for your kitchen staff. It's now a stable, concrete asset that anyone on your team can follow perfectly every single time.
Okay, we have our recipe card. Now we need a way for people to place an order. That's step 2, serve. Technically, we do this by creating an API, an application programming interface.
And what's an API? It's simply the restaurant's order counter. It's the public-facing part of your operation where a customer comes up, gives their request, that's the input data, and gets their finished dish back, the model's prediction. It's the front door to your model's capability.
Finally, we have to ship the entire system. The engineering practice for this is called containerization, and a common tool for it is Docker. This step bundles everything, the model, the API, and all its dependencies into one standardized unit.
This is the real game changer. It's like creating a complete restaurant in a box. This box has everything: the recipe card, the order counter, and all the special equipment needed. The beauty is you can ship this box anywhere in the world, and it will set up the exact same restaurant, serving the exact same dish. This is how you get consistency and scale.
And this restaurant in a box is defined by a simple set of instructions in a file, usually called a Docker file. A command like from is like saying, start with a clean, empty kitchen. Copy brings our serialized model, our recipe, into the kitchen. Run installs all the tools and libraries we need, and finally CMD is the instruction to flip the open sign and start the API server.
Okay, so we've built our restaurant in a box. Now, where do we actually set it up? Well, the strategy really depends on what kind of service you're trying to provide. There are two main approaches. First is real-time inference. This is for things like chatbots or recommendation engines, where you need an answer immediately. Your restaurant has to be open 24/7, ready for an order at any second. The second approach is batch inference. This is for jobs like weekly sales forecasts. You don't need an instant answer. Instead, you can process a huge amount of data all at once, say every Sunday night. The restaurant only needs to open on a schedule. But here's something that is absolutely critical to understand. Deploying your model is not the end of the story. In fact, it's just the beginning of a continuous life cycle called ML Ops, or machine learning operations. See, once a model is live, you have to monitor it. The world is always changing, and over time, your model's performance might degrade as new data patterns emerge. That's called model drift. When monitoring tells you that's happening, it's time to retrain the model on fresh data, and then redeploy the new, improved version. It's a constant cycle. So, let's bring it all home. A model sitting on a hard drive has potential, sure, but a deployed model has actual value. Deployment is the bridge that connects your code to real-world impact. And if you remember just one thing, make it this. Think about deployment from day one. Don't treat it as an afterthought you'll get to later. That mindset is what separates a cool research project from a robust, real-world solution.